Everyone, my name is Sujit and I'm here to explain the topic underwater sensor networks for smart disaster management. Coming to the introduction part, technique of sending and receiving message under the utilization of sound propagation in underwater environment is known as acoustic communication. Underwater sensor networks have number of vehicles and sensors that deploy in a specific area to perform collaborative monitoring and data collection tasks. Traditionally, for the monitoring of ocean bottom, oceanographic sensors are deployed for record location and recover the instruments at the completion of task. The major disadvantage of traditional approach is lack of interactive communication between different ends. Recorded data can never get during any mission, and in case of any failure, recorded data will be destroyed. Underwater sensor networks support a wide variety of applications. For example, aquatic surveillance, river and sea pollution discovery, monitoring, oceanographic data compilation, and commercial exploit the aquatic environment. Underwater sensor networks can be utilized in any scenario from underwater warfare to the monitoring of environmental conditions. Underwater sensor networks face constraints like limited bandwidth, high propagation delay, 3D topology, and power constraints. Radio and optical waves are not feasible for communication at each point of ocean. Coming to section 2, underwater sensor networks architecture. Underwater networks physical layer utilizes aquatic acoustic technology for communication. Limited bandwidth, capacity, and variable delays are characteristics of acoustic technology. Therefore, new data communication techniques and efficient protocols are required for underwater acoustic networks. Designing the network topology requires significant devotion from designer because underwater network performance is generally depending upon topology's design. Network reliability should increase with efficient network topology, and network reliability should also decrease with less efficient topology. Energy consumption of efficient network topology is highly less as compared to incorrect and less efficient topology design of underwater network. Design of topology for underwater sensor network is an open area for research. Underwater sensor networks architecture is shown in figure. Here the picture shows 2 and 3 dimensional networks architecture for UWSN regarding communication. Underwater sensor networks in 2 dimensions. Deep ocean anchors are utilized for collection of sensor nodes in 2-dimensional underwater sensor network architecture. Anchored underwater nodes use acoustic links to communicate with each other or underwater sinks. Underwater sinks are responsible to collect data from deep ocean sensors and provide it to offshore command stations using surface stations. For this purpose, underwater sinks are provided in the company of horizontal and vertical acoustic transceivers. Underwater sensor networks in 3 dimensions. Activities required to present 3-dimensional environments new architecture which is known as underwater 3-dimensional networks is used. Sensor nodes float at a different depth to monitor a specific activity in 3-dimensional underwater networks. Traditional solution regarding underwater 3-dimensional sensor networks is the use of surface buoys that provide ease in deploying such a kind of network. But this solution is vulnerable to weather and tampering. Propagation of a phenomena of underwater sensor networks. This is section 3. Acoustic communication regarding underwater environment is a complex phenomenon because a lot of environment factors affect acoustic communication. These factors are variable like long propagation delays, environmental noise, path loss, Doppler spread, and multipath effect. Underwater environmental factors make acoustic channel highly variable. They also create bandwidth dependency upon both frequency and distance between two nodes. Path loss. This is the subtopic of section 3. When sound propagates from underwater environment, then some of its strength converts into heat. Sound wave propagation energy loss can be categorized into three main categories, which are described below. First one is geometric spreading loss. When source generates acoustic signal, it propagates away from the source in the form of wave fronts. It is independent of frequency, however, depending upon distance covered by wavefront. Geometric spreading is divided into two types. First, spherical spreading that depicts deep ocean communication. Second, cylindrical spreading that depicts shallow water communication. Second one, attenuation. Attenuation is defined as wave energy converted into some other form of energy, such as heat energy, absorbed by the medium used. Next, third one, scattering loss. Deviation regarding the line of sight of the signal or change in angle is generally a physical property. Underwater channel also contains this property that affects acoustic channel data transmission during communication. Next, multipath. Sound propagation in shallow water is influenced by surface reflections, while deep water propagation is affected by bottom reflection. That becomes cause of large and variable communication delay in acoustic communication. A major cause that makes acoustic signal weak is called multipath effect. That becomes cause of intersymbol interference, which also makes acoustic data transmission difficult and erroneous. Doppler spread. Because of channel flaws, wireless signals practice a diversity of degradations. For example, electromagnetic signal affects by interference, reflections, and attenuation. Acoustic signals regarding underwater are also affected by same kind of factors. Underwater acoustic channel is complex channel due to time variation and space variation. The relative motion of a transmitter and receiver that causes the mean frequency shift is called Doppler shift. Next, section 4, related studies. Presently, underwater communication system utilizes electromagnetic, optics, and acoustic data transmission techniques to send data among different positions. Electromagnetic communication technique is affected by conducting nature of seawater, while optic waves are applicable on very short distance because optic waves are absorbed by seawater. Acoustic communication is only one technique that has better performance regarding underwater communication due to less attenuation in seawater. Next, fifth section. Issues and challenges regarding underwater sensor networks. In this section, issues and challenges regarding underwater sensor networks are described, which makes underwater communication hard and problematic as compared to terrestrial sensor network communication. In underwater sensor network, issues and challenges like reliability and efficient utilization of acoustic communication link, optical packet size selection for communication, power consumption, distributed localization, environmental effects, media access control, and network routing protocol still need to address. First, environmental effect. Marine organisms are affected due to anthropogenic sound which is emitted in underwater environment in various ways. Example, organs of hearing are affected in shape of hearing loss. High potential sound waves which are received by marines can injure and also can become the cause of their death. Presently, underwater communication utilizes different kind of communication methodologies. Example, method, 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 methodologies. Example, optic, electromagnetic, and acoustic. Next, cognitive communication. Because of attenuation, the available communication frequencies are mostly limited, usually from tens to hertz to hundreds of kilohertz in underwater environment. Mostly artificial acoustic systems and natural acoustic systems utilize the frequency band from 1 kilohertz to 100 kilohertz. That makes the acoustic channel crowded. Frequency utilized by artificial acoustic systems is overlapping with natural acoustic systems, for example, marine mammals. Next, MAC issues. Acoustic channel effects from various problems, for example, narrow bandwidth and huge transmission delays. Furthermore, acoustic channel has exclusive challenges regarding media access control. Media access control protocols have two main categories. First is called scheduled protocol that has avoided collision between transmission nodes. Second is known as a contention based protocols where nodes compete each other for sharing a signal channel. Next, channel utilization. Designing a highly utilizable channel is a great challenge due to the characteristics of underwater environment. For example, multipath propagation, which results in fading and phase fluctuations. Doppler effect is another problem which is observed due to the movement of both the sender and receiver nodes. Speed of sound and underwater noise are further factors which influence the performance of acoustic channel. Next, conclusion and future directions. In this discussed several techniques of underwater sensor networks. The objective of the revived techniques is to overcome the underwater challenges and to give directions to future researchers. In this perspective, we have presented future directions which are still not yet explored in this research area. A better communication technique can be proposed by considering environmental effect during communication. Thank you all.